All right, so welcome to this class. We'll be looking at questions on Introduction to General Chemistry. As usual, okay, if you have any questions on whatever I'm going to explain, you are free to ask. Okay, just unmute yourself and then you can ask the question. Then I'll be able to help you. Okay, for those who don't know me, my name is Tutor Paul Solutions from Discrete Learning Institute. Okay, so Discrete Learning Institute, it's an online education platform. So we offer lessons in math, okay, chemistry, physics, and biology first year. So if you're interested in joining our team, you are very much welcome to join. We have a very nice platform, okay, that you can use to learn at your own time, at your own pace, anywhere where you may be. All right, so the first question here, they're saying define each of the following terms applied in the scientific method. Okay, define each of the following terms applied in the scientific method. So they've given us hypothesis here, they've given us theory, and they've given us the law. And then they want us to define this. Okay, so before we can even define them, of course, I've written the definitions down here. Okay, I would just like us to learn about the scientific method as a whole. Like, what is the scientific method? What do we use it for? Okay, so let's learn first about the scientific method, and then we'll come back and define these simple three terms here. Okay, so you can see on my screen there, I've outlined 9 steps, okay, of what the scientific method is all about. Okay, so if you have any questions, okay, make sure you ask me as I'll be explaining. All right. So we start from the definition. So if you're using a phone, okay, you can just put your phone in landscape so that the screen is bigger enough for you to see. Okay, don't put it in portrait. Okay, you won't be able to see some things. All right, so let's start. So by definition, we say that the scientific method, okay, the scientific method is a systematic process used by scientists to investigate natural phenomena, okay, to discover new knowledge or to solve problems using experiments and evidence, okay? So this scientific method ensures, okay, that the results are accurate one, okay, they are reliable and they are verifiable. Okay, meaning we can verify them. And then we have about 9 steps, okay, but they usually summarize them into 5. But I just want to talk about everything, okay, on how this scientific method happens. Okay, so the first step there is observation. Okay, so observation, this is when the scientist, or it can be anyone, they notice a problem or a pattern, okay, using their senses, or they can use instruments. Okay, so that's the first step, observation. You notice a pattern or a problem using senses or instruments. Okay, so for example, a student observes that salt water dissolves faster in um, a student observed that salt dissolves faster in hot water than cold water. So that's an observation that you've made. Okay, you've observed that, oh, when I get hot water, I put salt, it dissolves faster than when I put the salt in the what? In cold water. That's an observation. So that's the first step. And then the second step is identification of a problem, which helps you to form a question. Okay, so in this second step, a scientific question is formulated based on the observation. Okay, so remember the observation that we did here. The student observed that salt dissolves faster in water than in cold water, right? Okay, so now the question that we're going to ask ourselves is that, does temperature affect the rate of dissolving of salt? Okay, from this our observation here. So that means we have identified the problem and we are treating it as a question. Okay, so we're asking ourselves, does temperature affect the rate of dissolving of what? Salt. Okay, from there, the third stage is formulation of what we call a hypothesis. Okay, so a hypothesis is a testable prediction. Okay, you're just making a prediction that you want to prove that it's either wrong or it's correct. Okay, so this is a testable prediction. So you make the testable prediction now. So in this case here, for example, of the salt dissolving faster in hot water, okay, our hypothesis might be salt dissolves faster in hot water than cold water. That will be your hypothesis, okay? So now we want to prove this hypothesis. So how are we going to prove the hypothesis? We're going to carry out experiments. So that will be the process number what? Number 4. So here I was saying experiments are conducted, okay, to test the hypothesis. Okay. So experiments are conducted to test the hypothesis. So for example, we can take two beakers, okay? We can have a beaker A and a beaker B. So in this beaker A, we're going to put cold water. Maybe we put cold water with a temperature of about 20 degrees Celsius. And then in beaker B, okay, we put hot water with a temperature of about 60 degrees what? Celsius. Okay. And then now we are going to measure the time taken for salt to dissolve completely in both of these beakers. So we are going to put salt in those beakers at the same time. Okay, so we add a certain amount of salt to those beakers at the same time, and then we observe, okay, the time that is going to take for each of those water, okay, to dissolve the salt completely. Okay, so that is the experiment part. So from that experiment, we are now going to collect data. Okay, so this is the step number 5 here. So from this experiment, we are collecting data now. So here I was saying results are measured, data is recorded into tables, graphs, or chart. So for example, we are saying, okay, after doing the experiment, okay, the water I mean the salt that you put in beaker A okay, dissolved completely after maybe 90 seconds. And then the salt that you put in beaker B that had hot water dissolved after 25 seconds. Okay, so those are going to be your data collected. Okay, and then from there, we just have to analyze this data that we've collected. So that is the step number 6. So data analysis there. So here I was saying the results are calculated, compared, and interpreted. Okay, so this helps to see patterns or relationship. So in your analysis, for example, okay, if we continue with our sort example there, you can say in your analysis, you can say or state salt took 90 seconds in cold water. Okay, so say 90 seconds in cold water. Okay, that's your data analysis. And then 25 seconds in hot water. Okay, so you have analyzed your data. All right, so after um, analyzing like that, okay, you will be able to conclude just from these results here. You can say that this shows that as the temperature increases, okay, as the temperature increases, dissolving time decreases because this was cold water, it takes 90 seconds. Then hot water, it takes 25. So meaning that as the temperature increases, okay, as the temperature increases, dissolving time decreases. Okay. So that's what you can get from your data analysis. And then the next step now will be the conclusion. Okay, what are you concluding from whatever you've found there? So in your conclusion, you either state if the hypothesis that you had made is being supported by the data that you've collected from the experiment, or it's not being supported. So in this case, remember our hypothesis here, we said salt water, salt dissolves faster in hot water than cold water. So we can see that from the experiments, this hypothesis is going to be supported. Okay, so in the conclusion, we are going to say hypothesis is what? Supported. Okay, if the hypothesis is supported. So why are we saying that? Because from the experiment, we've seen that the salt dissolved much faster in the hot water than the cold water. Okay, and then from there, we go to number 8, which is the formulation of a theory. So this theory can only come about after doing a number of experiments. So for example, this was just experiment 1, and then you do experiment 2 again, experiment 3, experiment 4. And when you see that the results that you are getting from all those experiments that you are doing, okay, are the same, or they are leading to the same conclusion, then you come up with a what? A scientific theory. Okay, you come up with a scientific theory. So you can say, for example, after many similar experiments, okay, by many scientists, a journal explanation was formed. What was that explanation? Okay, is that the particles in water have more kinetic energy. Okay, so because of that kinetic energy, they move faster and they collide more with the salt, making it dissolve what? Faster. So that would be your theory based on the experiment that you've done. Okay, so that theory will just be supporting the kinetic theory of matter. Okay, and then once you come up with the theory, okay, the next step is to come up with the law. Okay, so how do you come up with a law? So a law, uh, it's quite similar with how you come up with the theory. Okay, so the law is um, a law is where you come up with a mathematical relationship. Okay, between uh, um, you come up with a mathematical relationship of the theory that you stated. Okay, that's what a law is. So you do a lot of experiments again. So if results are constant and universal, then a mathematical relationship is going to be found. Okay, so that mathematical relationship that we found is what we are calling as a scientific what? Law. Okay, so yeah, so that's how we go about the scientific method. So these are all the steps, okay, and I've explained them. So in our first question there, they were just asking us to define, is it a theory, a law, and a hypothesis? Okay, but I thought it wise that you guys should know everything here. So you've known everything about the scientific what? Method. This is how it happens. All right, so any questions there? Okay, so if there are no questions, we can go back now and answer this question after we've known what the scientific method is. So here they're saying define each of the following terms applied in scientific method. So hypothesis. Okay, so a hypothesis, this is just a tentative explanation or a prediction made to explain an observation which can be tested by what? By experiments. And we saw an example there of the salt dissolving fast in what? Water. Okay, and then what is a law? Okay, I mean a theory. Okay, so a theory is a well-tested and widely accepted explanation of natural phenomena based on many experiments and observations. Okay, so I clearly said that for you to come up with a theory, you have to do a lot of experiments. So if all those experiments are giving you the same conclusion, then you can come up with a what? A theory, which is just a well-tested and widely explained um, and accepted explanation for natural phenomena. Okay, and then from there we can define what a law is. So a law is a statement or mathematical relationship that describes what always happens in nature under given conditions. So for example, okay, of the common laws that we have in science, okay, chemistry, physics, we have the Newton's laws. Okay, so these Newton's laws, okay, they came up about through a process of scientific what? Method. Okay, so very soon in physics, you're going to learn about the Newton's laws. Okay, I'm sure you learned about them in secondary, right? So we have the first law, we have the second, we have the third law. So here now at the university level, you're going to learn them in detail, and it's going to be very interesting as you learn these laws. All right, so that is question A. Okay, question A, we are done. And then we go to something else now. Okay, so this one here, they're saying use exponential notation to express this number here to one significant figure, five significant figures. Okay, so exponential notation is the same as scientific what? Notation. So just want to express 1.325. Want to express this number, okay, to one. Okay, want to express it to one significant figure, but we should not change its value significantly. Okay, so how can we express this to one significant figure? Okay, maybe I should talk about the rules of scientific figures a little. Okay, so we have about, is it 4 or 5 rules that are very important, okay, in determining what number is significant and what number is not significant. So the first rule is that all non-zero numbers, okay, are significant. So as long as a number is not zero, it's 1, it's 2, it's 7, it's 4, it is significant. Okay, so all non-zero numbers are significant. And then we can talk about the leading zeros. So all leading zeros, okay, are not significant. Okay, are not significant. So what do we mean by leading zeros? These are the zeros, okay, that are in front of non-zero digits. So for example, if I write 0.0005, so these zeros here are in front of the 5, which is a non-zero digit. So these leading zeros are never significant. Okay, they are never significant in any situation. Okay, they are never significant. So if they ask you how many significant figures are in this number, you're just going to count 1. Okay, these zeros here are not significant. All right, and then the other rule is on captive zeros. Okay, so captive zeros simply means zeros that are between non-zero digits. Okay, so zeros that are between non-zero digits are always significant. So for example, 5005. So we can see these zeros are between two non-zero digits there. So these ones are counted as significant. So if I was to count the number of significants here, okay, it would be 1, 2, 3, 4. Okay, there are 4 significant figures there. Okay, so captive zeros are always significant. And then the other rule is about the trading zeros now. So the trading zeros, this is where most of the students they get it wrong. Okay, trading zeros. So trading zeros are in 2 parts. Okay, trading zeros are in 2 parts. So I'll write 2 numbers here. So 2 0.000, and then I'll just write 2 0, 0, 0, 0. Okay, so I've written 2 numbers there. So you can see the other one has a decimal point. Okay, the other one does not have. So trading zeros are the zeros that come after a non-zero digit. So you can see there's 2 and then the zeros. Here again, there's 2 and then the zeros. So these trading zeros can either be significant or they can be non-significant. So the trading zeros are only significant if there's a presence of a decimal point. So for example, in this number here, we can see a decimal point there. So it means all these trading zeros here are going to be significant. Okay, but if there's no decimal point in that number, then the trading zeros are not significant. So if I count the number of significant here, I'll say 1, 2, 3, 4, 5. There are 5 significant figures there. But if I count the number of significant figures here, it will just be 1. I'll just say 1 significant figure. Okay, so trading zeros can only be significant if there's a presence of a what? A decimal point. So in short, if I also write this same number, but I write it as 0, 0, 0, 0, and then I write point, okay? Because of this point here, these zeros here become significant, okay? Those zeros there become significant. So always know those rules, okay? Because they're the most important when you're dealing with it. Significant figures. So now they want us to express whatever they have given us there, which is 101.325, okay, as a number that has 1 significant figure. Okay, so how can I do that? I'll just express it in exponential notation. So I'll move this point 1, 2 times. So it will be 1, okay, 0.01325 multiplied by 10. Okay, since now I was moving to the left and I've moved 1, 2, so this will be to the power 2. Okay, so now you ask yourself, is this number that I've gotten having having 1 significant figure? No, because here this is significant, 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 this is significant. So it has 1, 2, 3, 4, 5, 6. It has 6 significant figure. So what can I do to make it have 1 significant figure? Okay, I'm just going to remove this part here. Okay, I'm just going to remove that part because this is 1 point something. So we can round it off to 1. So it's just going to be 1 multiplied by 10 to the power what? 2. So this number now has only 1 significant figure. Okay, so that's how we can express this guy to 1 significant figure. Just write 1 times 10 to the power what? 0. Okay, so any questions there? . Okay, let's look at the other one. So the other one, they're saying use exponential notation to express the number, okay, to 5 significant figures. Okay, so 5 significant figures. Uh, First, we express it to scientific notation, like the way I've written it there, and then we just round it off to 5 significant figures. So this one has 6, so I'm going to round it off from here. So this is 5. So I add 1 to the number uh, before it. So this will be 1.0133 times 10 to the power 2. So this number here has 5 significant figures. 1, 2, 3, 4, 5. All right, so any questions there? Okay, what if they said uh, give it to 2 significant figures? Then it will just be 1.0 times 10 to the power 2. So here, this 0 counts as significant because there's the presence of a decimal point. Okay, so to 2 significant figures, we'll write this here. Right, we'll move here now. They're saying state the difference between precision and accuracy. Okay, we taught this topic to full length. Okay, we talked to this, we taught this topic to full length. The video's there on YouTube. You can go and watch it. Okay, so we said these 2 things here, they differ. Okay, we have the precision here and the accuracy. Okay, so we said the precision is just the degree of agreement among several measurements of the same quantity, while the accuracy refers to how closely a measured value agrees with the correct value. Okay, so if, for example, the true value is given as 25 grams, okay, and then your measurements, you find 24.9 gram. You see that this 24.9 grams is very close to a true value, right? So we're going to say this here is accurate. Okay, it's accurate. And then about precision, it's how close the measured values or several measured values are to each other, okay, to each other and not necessarily to the true value. So for example, if I did maybe 5 measurements of this uh, 25 gram, then I find maybe 20.1 gram, 20.19 gram, okay, 19.99 gram, okay, maybe another one is 20.05 gram. So we see that all these measurements that I've taken down here, okay, they are very close to each other, but they are not close to the true value because the true value is 25. Here it's 20. Okay, so these measurements here are going to be precise, okay, because they are close to each other, but they're not going to be accurate because they are very far from this. Okay, so that's the difference between accuracy and precision. When you talk about precision, it's how close the measured values are to each other and not necessarily to the true value. When you talk about accuracy, okay, it's how close the measured value is to the true value. So that's the difference there. All right, and then next we perform the following mathematical operations and express each result to the correct number of significant figures. So now let's look at this. So this one here is 9.04 minus 8.23 plus 21.954 plus 81.0. Okay, so we just have to follow a simple rule. Okay, so when you are adding or when you're subtracting, okay, numbers that have different number of decimal places, okay, the final answer should have the same number of decimal places as the number that had the least number of decimal places. So you can see here, this guy has 2 decimal places. Okay, there's 1, 2. This one here has 2 decimal places. This one here has 3 decimal places. This one here has what? 1 decimal place. Okay, so meaning that when you add all this, the answer that you should get, okay, should have the same number of decimal places as the number that had least. So it means here the answer should have what? 1 decimal place. That's the rule when you're subtracting or when you're adding. Okay, so this thing here was in brackets like this, and then it's been divided by this number here. So let's first add whatever is in the bracket. Okay, so what do I get when I do this? Okay, so 9.04 plus 8.23 plus 21.954 plus 81.0. Okay, so what I get there is what now? Okay, let me redo this. So I have 9.04 plus 8.23 plus, oh, that is minus. No wonder I'm surprised. So that is minus 8.23 and then plus 21.954 plus 81.0. Okay, so this one is going to give me 103.764. So now remember we said the answer after adding or subtracting should have the same number of decimal places as the number that had the least. So this one had one decimal place. So I have to round this off to one decimal place. So I'll round it off from here. So this 6 is greater than 5. So we add a 1 to this 7. So the final answer here will just be what? 103.8. Okay, so now this answer we are dividing it with that guy. So it will be 103.8 divided by 3.1416. So now when you are dividing now or multiplying, there's another rule that you should follow. Okay, so the one for the decimal places is when you are adding or subtracting. But when you are multiplying or dividing, okay, then your answer should have the same number of significant figures as the number that had the least number of significant figures. So there now you count the number of significant figures. So when I look at this guy, how many significant figures? 1, 2, 3, 4. So 4 significant figures. When I look at this guy here, how many significant figures? 1, 2, 3, 4, 5. So 5 significant figures. So it means the answer should have 4 significant figures. So punch this first of all on your calculator. So 103.8 divided by 3.1161. So that will give me 3. Okay, it will give me 3.04048892. Okay, so that's the answer that I get there. Okay, that's the answer that I get. So we said the final answer should have the same number of significant figures as the one that had the least number of significant figures. So this guy here had 4. So it means my final answer should also have 4. So my final answer here will just be 3.04. So that will be my final answer because it has 4 significant figures as well. All right, so any questions there, guys? Any questions that you have? Okay, so no questions. Let's look at part 2, that one. Okay, so part 2, let me rewrite it. This is 0.470 divided by 0.623 plus 80.705 divided by 0.4326 minus 2.526 divided by 3.1. Okay, so we always follow what you guys used to call as board mass. You remember the board mass? We follow it. So brackets of division, multiplication, addition, and subtraction. So we are going first to start by dividing, and then we can add and subtract. So here, how many significant figures can I see here? 3 significant figures. Even here, 3 significant figures. So it means the answer that I should get should also have 3 significant figures. So 0.470 divided by 0.623, that gives me 0.754. And then the number continues to go, but I'm only interested in 3 significant figures. So I just end it there. And then plus this one, on top, we have 5 significant figures. Down, we have 4. So it means the answer should have 4. So that would be 80.705 divided by 0.4326. So that one gives me 18. Remember, I'm only interested in 4 significant figures. So that would be 186.6. So this is 4 significant figures. Okay, so the number continues to go, but I'm only interested in the 4 significant figures. Then minus here, the one down here has two significant figures. This one has 4. So it means the answer should have 2. So 2.526 divided by 3.1. That gives me a very big number on my calculator, but I'll only write it to 2 significant figures. So that would be 0.81. Okay, I'm done with the division. I go to the subtraction and the addition. Okay, so the subtraction and the addition, you can do them in any order. It doesn't matter. So this one has 3 decimal places. This guy here has 1 decimal place. This guy here has 2 decimal places. So it means my answer should follow the one with the least. Okay, so it should have 1 decimal place. So I'm going to add this on my calculator. So 0.754 plus 186.6 plus 0.81. So I get 188.164, but we said the answer should have 1 decimal place. So this will just be 188 point, 188 point what now? Okay, 188 point, okay, I'm finding point 2. Okay, because it should have 1 decimal place. Okay, so let me redo it. 0.754 plus 186.6 plus 0.81. Okay, still get the same answer. So 188.2, that will be our final answer there. All right, so any questions there, guys? Okay, then let's move. So the next question now is testing our knowledge of the metric system. We learned about the metric system in our first lessons. Okay, they are there on YouTube. We can search the channel Discrete Learning Institute. So here they said, show your understanding of metric prefixes by giving the name to the unit that equals the following. So here they have said 10 to the power minus 9 gram. So 10 to the power minus 9, okay, its prefix, this guy here, it's just the nano. Okay, so this will just be nanogram. Okay, so you get it from the metric table. I just didn't put the metric table here, but you can search it up on Google or anywhere. All right, and then the other one is 10 to the power 9 gram. So what is the prefix for 10 to the power 9? Okay, so 10 to the power 9, that is giga. So we write giga. So giga represents 10 to the power 9. So that is giga, gigagram. Okay, and then what else? The 10 to the power minus 15, what is that? Okay, anyone who can remember? Okay, what is 10 to the power 15? Hello? Anyone who can remember, what is the prefix for 10 to the power minus 15? Okay, so 10 to the power minus 15, okay, gram, this 10 to the power minus 15, this part here, okay, indicates what we call as the femto, okay, so femto, like this. So fe and then m and then to. So whenever you see femto, just means 10 to the power minus 15. So that is gram. So I remember in our first years, as when we were doing natural sciences, we even made a song about this thing so that we can't, we do not forget. Okay, so the song was going something like pica nano micrometer centidesi kilo mega giga tera. Yeah, and then those things were, we sang them in order so we knew the value of each one. So pica, okay, or pico, whatever you can say it. Okay, so pico or pica, this is 10 to the power minus 12. Okay, pica nano, okay, the nano is 10, which is what, minus 9. Okay, and then pica nano micro is 10 to the power minus 6. So you see, I still have it in my head. And then milli, pica nano micro milli, okay, centi, 10 to the power minus 2. Okay, so they're still in my head. So pico, okay, it's minus 10 to the power minus 12. And then when you go to nano, this power increases by 3 to go to minus 9. So I'm saying increase here because these are negative numbers. So this guy here is actually less than the minus 9. So they increase by 3 like that. Okay? Yeah, so you can also try to make whatever is going to make you remember these things, okay, uh, in your head, because they are going to come, okay? Test one, they're going to be there. Okay, whether you want it or not, they are going to come. So it's just better you start knowing them, okay? Because you're going to find them. And it's very bad because we've told you that they're going to be there, and then you go to the test, you don't know them, and then you find them, okay? It's very bad. So make sure you know them. All right, we move to the next question, which is question F. So F is very simple because we're just converting temperature. So here they're saying convert each of the following temperatures from degrees Celsius to kelvins. Okay, so we know that the temperature, okay, in kelvins is equals to the temperature in degrees plus 273.17. That's the formula. So the first one there is minus 38.9 degrees Celsius. I add 273.1. Okay, so what do I get here? So my calculator, I have minus 38.9 plus 273.15. Okay, so make sure that in your final answers here, you are considering the number of significant figures, okay? Because they are going to deduct marks, okay, if you are not considering them. So remember the rule that we said, when we are adding, the answer should have the same number of decimal places as the one that has the least. So this one has 1 decimal place, this one has 2. So it means my answer should also have what? 1 decimal place. Okay, so when I add this, I get 234.25. These are kelvins now. Okay, but this has 2 decimal places. So you have to express it 1 decimal place. So that would be 234.3 kelvins. So this is the correct answer here. If you write this one, they're going to deduct some mark. Okay, so you'll be wondering, oh, I know the formula, but you didn't get the full marks. Okay, and then the other one, this will be equals to 119.3 degrees plus the 273.15. Again, you can see this one has 1 decimal place. Okay, this one has 2. So it means my answer should also have 1 decimal place. So what do I get here? So 119.3 plus 273.15. So that is going to give me 392.45. But this one has 2. So I'll round it off to 392.5 what? Kelvins. So that would be the answer there. Okay, so if you wrote this one here, they're going to deduct some marks. Okay, so any questions there, guys? Any questions? Okay, so next we look at part G. So part G is writing chemical formulas, okay, for compounds. So here they're saying state the chemical formula of each of the following compounds. So there's perchloric acid and phosphorus pentachloride. Okay, so perchloric acid, this is just simply an acid that is made of the hydrogen atom and the chloric radical. Okay, so the chloric radical is Cl and then O minus. This is the chloric radical. Okay, and then I also said it's made up of the hydrogen. Okay, so now the secret to writing formulas for these compounds is just knowing the valence of whatever is involved there. So here in the perchloric acid, there is hydrogen. Hydrogen has a valence of 1. Okay, and then there's the chloric radical. So the chloric radical is this guy here, and it has a valence of 1 as well. So these things are just going to combine, and then they will exchange their valences, I mean. Okay. Oh, I forgot to take a 4 here. So the chloric as eka4 there. Okay, so this is the perchloric radical, and then this is the hydrogen. Okay, when you combine them, they're going to form perchloric acid. So these guys here are just going to exchange the valences. So this valence goes to this valence goes to this. So the formula that I have there is HClO4. Okay, because even if I put the one there and I put the one there, it's still the same thing. So that's the formula for the perchloric acid. Okay, I shared a video in the group on how we actually come up with these formulas. Okay, so you can watch it to get other examples. Okay, what about the second one? So the second one has phosphorus, and then here they're saying pentachloride. So this penta here simply means there are 5 chlorines. Okay, simply means there are 5 chlorines. Okay, so phosphorus has a valence of 5. Chlorine has a valence of 1. So these guys are going to exchange. So this 5 goes to the chlorine, this one comes to the phosphorus. So the formula there will just be P1 and then Cl5. Or you can write it as PCl5. You can see where the pentachloride comes from. So you can see there's a 5 there on the chlorine. All right, so any questions there, guys? Okay, so if there are no questions, let's look at the last question, which is on um, isotopes. Okay, so I think the class that we had on Monday, I was discussing these same things. Okay, how to find if the mass is missing or the percentage abundance is missing or whatever you're finding. Okay, so we said the relative atomic mass is equals to, okay, the mass of isotope 1 multiplied by the percent of isotope 1. Okay, this percent is always over 100, and then plus the mass of isotope 2 multiplied by the percent of isotope 2. So that is if you have 2 isotopes present, like in this case. Okay, if you have 3, then you are going to add plus mass of isotope 3 plus percentage of isotope 3. But we don't need it there because we only have 2. So if we read the question here, they're saying europium has 2 isotopes whose relative abundances are these. So these are the percentages, okay? Given that the average atomic mass of europium is this. So this average atomic mass is the RAM that they are talking about. Okay. And the mass of the relative abundance, and the mass of an isotope with relative abundance 52 is this. Okay, determine the mass of the isotope whose relative abundance is this. Okay, so there we've been told that this guy that has 52 has this mass. Okay, so we can take that as mass 1 and percentage 1. So the RAM, which is the average atomic mass, is 151.96 is equals to mass 1. I'll get this one as my mass 1, 152.92 multiplied by the percent, which is 52 over 100. Plus mass 2, I don't know it, is what I'm finding. So they're saying determine the mass of the isotope whose relative abundance is 48. So here the percent is 48 divided by 100. Okay, so from here, what do we do? This is simply 151.96 is equals to, then I multiply whatever I have on top there. Okay, so that is 152.92 multiplied by 52. I get 7,951.84 over 100. And then plus this one here, you just be 48 M2 divided by 100. Okay, so this is over 1. So this is 151.96 is equals to, here, this guy here is going to be 100. Okay, so 7951.84 plus this one is 48 M2. So this one is over 1 here. So we can do a cross multiplication like that. Okay, so once we do the cross multiplication, we're going to have the following. This guy here is going to be 15196 is equals to 7, okay, 951.84.48, plus 48 M2. And then this guy goes to the other side. So it's 15,196 minus 7,951.84 is equals to 48 M2. Okay, what is the answer here when I subtract? So 15,196 subtracted by that, I get 7,244.16 is equals to 48 meters squared. Yeah, at meters squared. This is M2, right? Okay, so now to find the M2, I'm just going to divide both sides by the 48. So divide this side by the 48, divide this side by the 48. So meaning M2 is going to be equals to this guy divided by the 48. Okay, so I'm going to get 150.92, and this mass is an atomic mass unit. Okay, so any questions there, guys? Any questions there? Okay, so if there are no questions, I think I'll end here. Okay, I wanted us to solve topic 1. So this is topic 1. So we're done. So this one in test 1 carries 25 marks. So you have to know everything that I've talked about in this video. Okay, the same questions won't come, no, but the same concepts are going to come in test 1. Okay, so I'll end here for today. Okay, but for those who are interested in our lessons, okay, we actually have a website that has everything that you guys need. Okay, we actually have a website that you guys need. So when you go to your Chrome, okay, just search for Discrete Learning Institute. I mean discretelearning.com. Okay, so you just type in there discretelearning.com. It should come up, and then you click search. Okay, so once you search, this is our website here. So there are different courses that you want there. So you can see math, chemistry, physics, biology. So you can register for any course of your choice. Okay, you can register for any course of your choice. For example, if we are solving chemistry, right? So if you go in this folder for chemistry, okay, you're going to find 2 folders. So you guys are taking general chemistry. That's for first year. So you go in general chemistry there. Okay, and then here in general chemistry, you're going to find topic lessons, summarized notes, tutorial sheets, past papers, and even lab report samples. Okay, so this is a very good platform for you guys to learn. So if you go in topic lessons here, we've made lessons for all the topics that you're going to cover this year. You can see from introduction to chemistry, units, accuracy and precision, whatever I was talking about, the videos are here, and also they have notes that you can read at any time. So you can learn at any time, anywhere, even in your blankets at your own pace. Okay. And then, so these are just the topic lessons. If you want, you can go to the folder for the tutorial sheets. You're going to find tutorial sheet videos there. So you can go there, you find tutorial sheet videos. You can go there, you're going to find the past paper videos. So you can be using them to revise. Okay. So make sure you subscribe to this platform, and then you'll be using it. Okay. Anywhere, anytime. And we also have a mobile app. Okay, so this mobile app here allows you guys to download the videos that are on our platform. So you go to Play Store, you search for Discrete Learning Institute, and then the app is going to come. So you install that app, okay, and then once you subscribe for whatever course that you're going to subscribe, okay, you'll be able to download all the videos that are here. So you can download the videos, okay, and then after you download the videos, you can even watch them offline. So you don't always have to have bundles when you are learning using our platform. So you can install the app, download the videos. Even without internet, you'll be able to access the videos, and you can watch at any time that you want. All right, so thank you so much. This has been Tutor Post Solutions from Discrete Learning Institute. Until next time, learn fast, learn easily.